All right, this will be an advanced look at vector addition, just kind of going over some shortcuts and reminders of things that are a little bit more difficult. Even if you watched the basic one, so that would be helpful. And if you didn't watch the basic one, on the screen right now is the end of the basic problem. If you need to flip back to this at any point in time, we found the individual vectors right here. We added them all together. We did the stuff with r and theta at the end, just basic vector addition. So let's go ahead and erase this here real quick. There we go. Take a quick second here. Maybe. Erase all that and go over just a few differences. I'll do that one different too. Yeah. Okay. First thing I'm going to do a little bit different is instead of 6 kilogram meters per second at negative 30, I am going to write this a little bit different, but it's the exact same vector. So we're going to use 6 kilograms meters per second and assume that it was at positive 60 degrees from the negative y. So this actually ends up in the exact same spot. I'll go ahead and show you that real quick here. All right, so if I sketch out again, just like we just did, instead of negative 30 coming from here, we're going positive 60 from there, and again, A ends up the exact same spot, although technically our angle is here. And again, we have a vector that should be in the first, but due to a negative magnitude here, comes down into the third, and our final result should still be over here, that 13.86 kilograms meters per second at 249 and change degrees. Okay, so what are the things I want to go over? Number one, how do I do this a little faster? What are decent shortcuts? One, you know that you got to break down individual vectors, and at the same time, we're going to have to add up all of them. So the first easy thing to do is just go straight to adding all of them while you're finding them individually. Okay. Number two, just like always, we have to find the vectors, but what I'm going to do here is I'm going to go and write 6 kilograms meters per second, and then go cosine of, actually, no, not cosine, meters per second, and we're going to go with sine of 60 degrees. For starters, let's talk about the sine. Okay, the sine comes from the fact that my angle is right here. Since it's not measured from the x-axis, and this is going to happen, you'll see the x line I just drew is in fact opposite of that angle, and so sine is necessary instead of cosine. Now, you are absolutely welcome to, instead, since you know this is 60, you also still know that's negative 30, and go back to using cosine of 30. But oftentimes problems are vastly easier if you just work with the variables given to you, so using sine instead of cosine. Next, should x be positive or negative? I don't worry too much if there is a negative on the variable or there's not, or what the magnitude is, like right here. I have a sketch in my head of where this is supposed to go. I know it's supposed to be down here in the fourth quadrant, so I know my x is positive. So you don't have to write the positive. Obviously, that's another shortcut, but I'm just going to highlight that right here. Next, I'm going to go to the next vector and find its x. I can see already that it's supposed to be negative, so I'm throwing a negative up over here. I am not worrying a second about that guy right there, or specifically, I just know it's supposed to be in the third quadrant, so that's why I threw the negative over there. And the magnitude? Well, since the angle is measured from the x, I know that I can use cosine in this case. So this is going to be minus 14.14 kilograms meters per second cosine of 45 degrees. Okay, I don't have to worry about that being 135 or 225 or negative 135 because I've already taken care of the sine right there. With the exact same thing with the y. Okay, the y component, again, the y component is here on the first one, so it's cosines, and I can see now it needs to be negative. Okay, I can see my other one is supposed to be negative, so I'll take care of that ahead of time. And this is going to be 6 kilograms meters per second. Since it's adjacent, like I said, that will be cosine of 60. And this one over here will be 14.14 kilograms meters per second sine of 45. Again, don't need to worry about the angle because the sine's taken care of. Adding all these up, you should get that the first one is once again negative 4.8 kilograms meters per second x hat, and that this is negative 13 kilograms meters per second y hat. From this point, everything is pretty much exactly the same. I'm fine if you don't show the equation. I would still show the numbers. So to get r, I would still do obviously negative 4.8 kilograms meters per second x hat squared plus negative 13 kilograms meters per second y hat squared square root. One advanced thing I would say, or sort of advanced I suppose, is you'll notice that because of these squareds, the negatives inside will always cancel each other out. In the work, like I just did, always show the negative, okay? But when it comes to your calculator, never plug the negatives in. You know they're going to cancel anyway. If anything, they're only going to screw you up if you accidentally put parentheses in the wrong spot. So this should end up as 13.86. Another, I guess, sort of advanced thing is you can check yourself very easily here, because obviously that magnitude, basic rules of trig, should always be bigger than either of the components, right? You should never get smaller than 4.8 or 13 because this is the hypotenuse. And of course, angle, inverse tangent, just like on the basic one, we have to put the y on top, which is why those y hats and x hats can be super helpful. Negative 4.8 kilograms meters per second x hat. And again, I can see that there's two negatives here, so this better end up in the third quadrant. Okay, your calculator's not going to tell you that. It's going to cancel them. So you can either A, memorize that the second and third will always be the ones to screw up, or B, when this spits out 69 and change for its angle, you can recognize, hey, that's in the first quadrant. This final answer here, right over here, definitely not in the first quadrant. So I should probably have that 180 on there because of it. So 69 plus 180, 249.7 degrees. And there you go. There's your final